Hi, okay. So, if you didn't notice in the chat box, I put in sort of the little bit of the stats on the exam. High was 21, low was 11, average was 15. Um, it's a good, like, I'm kind of happy with the results. So by that, I mean, I didn't make the test too easy that someone got 25 out of 25. So the test was, I wouldn't say that the material was hard, right? I think everybody could do it if they had enough time, but we have to make a time constraint on it since it's basically open book, open note um, type of test. I'm also, you don't know this yet, but I'm a pretty easy grader. Also, to put a little encouragement into everybody, I gave about the same exam at UH Manoa, where the classes were huge. There were like 300 students at times. One semester I had 370. And I saw about the same average, but what I would see are some students that would do a fair amount that would do terrible. You know, like 10% of the class would get like 5 or 6. And those in-person class ones especially would have some real freebies on there, like just go to the periodic table and, pick out the element that's a metal, which we didn't really have on this test. We had a few easy ones on here. So the test is challenging. Anyway, I dropped the lowest exam score. This is only one, and depending on how you do, this might be the one you drop or something. But I wouldn't give anybody a non-passing grade based off this, right? I would say if you were the low at 11, that's a C. Then somewhere around the average 15, we switch to a B, and then the top 19, 20, 21 would be an A in the class. So usually on those, like I said, those huge classes in Manoa, I've seen people that get, um, and we used to do all multiple choice where it was only A through E. So statistically, you should be able to guess, it's 1 out of 5. And I would see people get 5 right out of 25, which anyway, so I think we're in a good position, and I don't think anybody should feel that they're in danger of not passing. But again, this is just one exam. The material tends to get a little harder or shift gears and just more chemistry, unless we don't have those first 2 chapters that are sort of intro science, and there wasn't too much of that on this test anyway. Okay, I went over also people that had trouble with getting on La Lima or like rounding or whatever, and you sent me your work. Please, in the future, if you're going to send me your work, it needs to be right after the class, and we'll always end the test like 10 minutes early, so that if you need to snap pictures with your phone and send it to me, it needs to be right afterwards, right? Because I email you the test. You can't send it to me hours later, because that means you could have taken hours to work on it. So anyway, I remember what it was like to be in school where you're cramming and studying, and after an exam, I mean, we're not 3 days a week, but from Wednesday, I'd imagine no one studied chemistry up till last night. And now I'm not going to cover any new material. So all I'm going to do is go over the answer key and talk about it a little bit more and explain, rationale and whatnot. And then I'll just hang around for the rest of the class period for anybody that wants to ask general questions, and then we can do individual ones too. But that's kind of up to if you don't want me talking about your exam in particular in front of other people or something. Okay. So this first one was just one of those basic combustion ones. This is about as easy as it gets for these combustion ones. And this one just asks you about the 2 products. So you didn't even need to worry about the O2, its actual number, but this is a real molecule, but anyway, C2H4, so you needed a 2 here for sure for the CO2. Then hydrogens, we've got 4, so you needed at least a 2. So this was going to be, 2, 4, 6, 8, something like that. So then it was looking at the oxygen, and since it's an even number here for the water, and there's obviously a 2 in carbon dioxide. That meant it was going to be an even number, so you wouldn't have to multiply the whole reaction by 2, and that could be the end of it. Or if you wanted to figure out the number of oxygens, then you could. 2 was a titration one, and pretty similar to what was on the practice exam or the slides. I forget exactly which, the study guide or whatever, but so 8.4 milliliters titrated with 17.1. So, 18 or 8 times 2 is 6, and this is 8.5. So it's really close to twice the volume, which means it should be about twice the concentration, right? If you only need half the volume, then it must be twice as concentrated. But then here's the actual math worked out, since it was fill in the blank one. So rounded off 2.036. And a couple people forgot to round or did 5 figures, and I went back in and gave you the point. 3 was one of these atomic mass, right? The weighted average, these made up percentages. It said 20.1%, which means you subtract from 100 to get the rest of it. You multiply that percentage times the individual isotope and add the 2 together. 20% is 1/5. So the normal average, 69 and 71 would be exactly 70. So that would be answer B, which obviously it isn't. And then A is too far the other direction, and then D doesn't make any sense at all. It's over the heaviest isotope. So if you're just doing it, I mean, there's none of the above that would be possible, but before you pick up your calculator, it's above. It can't be B or A. It has to be more than that, higher, and it can't be D. So it's really just, is it C or none of the above? 4. This one had all the right numbers, and I think somebody had emailed me. So these tests are so annoying to get up on Laulima. You have to copy and paste every problem in there. Anyway, I think on the test on Laulima, I forgot to delete these numbers. So it was a real freebie if you noticed that. But these were supposed to be blank, and then you go from the symbol. But it's iron, which is the 26th element. And then 26 plus 9 is 55. And then there was no charge indicated. So the protons was the first number, neutrons in the middle, and then the electrons last. So you were looking for 26, 29, 26, which all the rest of these are wrong. And I put an E, none of the above, at least one on every test. 5 is alkaline earth metal is group 2. And then the halogens is group 7. So a +2 and a -1 means you needed the 2-to-1 ratio. And I gave an example there. 6 was really similar to one out of the slides. It told you what the molar mass was, and then said the empirical C6H4. So you find that mass and then just divide it, and roughly 3. So then 3 times 6 and 4 made 18 and 12. 7 was probably the easiest one. You might have had to flip through your notes or I don't know, Google search Rutherford's gold foil experiment if you want. But if you just knew our generic view of the nucleus, the atomic current modern view, protons and neutrons in the nucleus, electrons are outside. So you didn't really need to go look that, search through your notes or the book or anything. 8, organic molecule has a molar mass 189.2, gives you the empirical formula. What's its molecular formula? So this is sort of the opposite a bit of the one above, or pretty similar, just different mass and numbers. 9 is a temperature one. I said there'd be one of these on there. This one was pretty straightforward. I think if people put E, none of the above, or had the 249 and didn't round it or something in your work, then I gave you the point. But anyway, right? From Fahrenheit, you need to go to Celsius and then to Kelvin. 10, it's a density one, so mass divided by volume. Then they're saying it displaces this amount of water, which is what you use as a typical freshman chem lab, where you drop some object in a beaker or graduated cylinder, and you see how much the water rises. That tells you the volume. And so this was just solving for the unknown, right? M was the thing that you were looking for. It gave you V and D. And so you just want to manipulate to get X or the mass by itself, which in this case meant multiply. And again, another rounding one. 11, I think, was, I know there's one long further. This was one of the more longer ones to do, because it said which compound has the highest percent mass. So, for example, like if I was doing the test, I'd be like, oh, this isn't, giving me a formula, and I have to figure out what the percent oxygen is. I have to find the percent on all 4 of these. And one of these has to have the highest, right? So E doesn't make any sense as an answer. So if I was taking the test, I would have left this to do as the last one, which you can really see here below, right? How many sig figs does it have? Leading zeros don't matter. It's just these 3. So the answer was 3, right? That one's a lot quicker than this one above. But the way you get there is, right, it doesn't matter, in this, since you're comparing them, let's say oxygen is 15.99 or 16.01, depending on, how accurate the periodic table you use is. It doesn't matter as long as you use the same number, because we're comparing them to one another. So mass of the oxygen times the subscript that's there. And then you put, and then that mass over the top of the total. And so not too surprising, right? Oxygen's not a heavy element, but water has the lightest element, hydrogen, attached to it. So if you wanted to find the actual value, you needed to do this. Or if water wasn't there, then the problem's a bit harder. But with water there, I know there's only 1 oxygen versus the other ones have 3 and 7, but the only other element there is the lightest element, and there's only 2 of them. So if you recognize that, you could have just gone with D, and that made this problem quick. But if you didn't recognize that, then you'd have to go through and find them all. 13 here was an attempt at limiting reagent, but not with chemicals, right? So basically this is sort of an intro type of problem to that concept. So since there's 1 frame to a car, you could obviously have 121 cars. That math's pretty easy. But 471, divide that by 4, so 117. But you can't make 7 or 3/4, all right, 75% of a car. Either you make a car or you don't. So 117 is the number, and then the wheels is the limiting. So 14. Several people missed this one, and usually the key thing you missed was here. It said oxygen gas, which is O2. Then it's just grams per mole, moles on the bottom, but in 1 mole of oxygen gas, there's 32 grams, not 16. So that's usually the common mistake in this one. 15 was meant to be a super easy one. You could even just Google search this and probably got it from there, or if you remembered, right? And I obviously made this up looking for other answers. It's a classic acid, starts with an H formula. So hydro, when it's just elemental or binary. So hydro goes in front, acid always at the end of every acid, and then it's iodine, which gets changed to the ic ending. So it becomes hydroiodic acid. 16 is a balancing one, and also up here, and this was up in the problem before, which gives you some information like about about these different species don't really make any sense, right? Saying aluminum metal reacting with oxygen gas, right? That's not oxygen gas. And this reaffirmed, the problem above. It needs to be O2. So that's the problem with A. Then B here, our problem is, right, 2 to 3. So that's not right. Then to get our it is O3, but to get the oxygens right, 3 is an odd number, so we have to multiply it by 2. So then you need a 3 here to get the O2 to 6. But then the 2 in front for the aluminum oxide then made the aluminum 4, so you need a 4 back here. So you could eliminate a few things to get there, but D is the right answer. Or you could have taken so you could have either eliminated them, or you could have just written aluminum oxygen, and then you had the correct formula even up here for aluminum oxide. Uh, 17. This is a dilution one, so M1V1 equals M2V2. It told you 27 mils of water is added to 123 mils of 0.23 molar HCl. Usually the common mistake on here is that since you're adding the water, 123 plus 27 is your new volume, or your V2. And the M that you're looking for should have gone down. So answer C doesn't make any sense. Answer D definitely doesn't make any sense. And 123 mils, you only diluted it a little bit, right? You added in less than its total. So this is a big dilution here, right? 0.039. It was what, 0.23. So that's 10 times, an order of magnitude. That would take about, 10 times as much water, essentially. But the proper way to do it was the plug and chug like this. Uh, 18 was meant to be pretty straightforward and easy. So when you add an acid and a base, and this is an acid, the formula is the same as that problem up above that had all the acid names. And then the trick here is magnesium has hydroxide has 2, right? Because magnesium's in group 2. So that was the idea of identifying that this was an acid base, but it also said salt, right? And we covered several of these titrations and just neutralization in general. This one didn't say it was a neutralization, but obviously implied by the two chemicals. So the salt, all salts is a metal and a non-metal. Like table salt is sodium chloride. This is just the magnesium bromide version of that. 19, the symbol that contains 44 electrons and 57 neutrons. So it said it kept it as X generically, but there's no, this one was sort of a backwards way where there's no charge there. So that tells you that it's 44 protons, because the protons and electrons equal each other. Then you add 44 to 57, and that element is ruthenium with a mass of 101. 20, here's another quick one. If you remembered how they work, right? You just go to the periodic table, you find what number vanadium is. It's the 23rd element, subtracted from 52, must be 29. So this is a good one in the sense of where I leave it blank of a numeric answer on NALEMA, because there's no rounding issues. Either it's 29 or you don't. And a pretty quick problem, right? The math is easy. 21, a classic molarity where you weigh out something, you go to the scale, and in this one you're weighing out 25.5 grams of KBr, then you dissolve it in the water. And the answers down here are, I'm moving them, making them up. So it wasn't a fill in the blank, so it didn't matter exactly what molar mass you used. If you used 119.1 or 0.01 or something, you still should have gotten something very close to this. right? I wasn't trying to trick anybody with rounding. Everything else was orders of magnitude off. I mean, with the exception of, well, no, this one's still an order of magnitude off. So 22, this is the one that would take the longest. So if I was taking the test, I would definitely leave this one for last. Because this is a classic, right? It's giving you the mass of 2 reactants. Then it's saying you make a gram amount of the product. So limiting reagent and yield means you need to figure out which one's limiting and which ones there's less of. And it turns out you run out of boron first. So even though the mass is more of the boron, the molar mass of hydrogen gas, and that's the other trick here, is that it's H2. So if you didn't put this, 2 for the mass in, you could arrive at a different answer. But so boron was the thing you run out of first. And then the mass of what you should get in theory, if it was 100%, is 3.192, et cetera. And this said, 3.00, divide the 2 and multiply by 100. So I know I went through that fast, but right, you can't just do this one on your calculator. You would need to write it down and make sure you keep track of things. And this one had lots of little nuance, and it was limiting reagent and percent yield. So you could argue it's sort of like 2 problems in one. So again, I would have left this one. Maltol, this is a real compound. It's not a made up one, but it has, I'm not sure if this is its correct formula or not, but maybe it is. But it does smell like cotton candy. I used to work with it, and it's, some chemicals are disgusting. This one actually is a nice odor to have to smell. This one is a real easy one too, right? Empirical formula just means the simplest, so lowest common denominator. What can you divide these by? You can divide it by 3. So 6, the 2 6s become 2, and the 3 becomes a 1. So this was meant to be, you could get to this answer and double check it and whatnot in 30 seconds or something, and so you have time for the other ones. 24, sort of a slight trick. There's a temperature where Celsius and Fahrenheit have the same value. So how would you figure this out? You just set up the equation where if they're the same value, that's Tc and Tf. You just put X in there and then solve for them. So you have to do a little bit of math to work it out and get there, but you should have arrived at -40. So this is one, I like this one. I mean, you can only ask it once in a class, but it's using the equation but it's asking you to do a little bit of math and manipulate the equation that isn't, I don't know, 100% obvious, I'd say. 25, these are made up numbers, but chemicals that are really concentrated, I'm not sure about soap, but they come in this range of molarity, so acids and other things that chemical companies sell, 15 molar. You add 13 mils to 200 mils a washing machine. What's the new concentration? So this is M1V1 is equal to M2V2. Certainly it's going to be more dilute. And then the other thing here is, right, this is milliliters and liters. So if you just plugged in 13 and 20, you'd get the wrong answer. So you can see over here, I moved the decimal point over. So you could have moved liters to milliliters. You could have made this, 200,000 milliliters, or you could have made the milliliters like I did, 0.013 liters. It doesn't matter which way you move it because the units are going to cancel anyway. And we were looking for a pretty small number. Okay, so what was our concentration? 15. So answer A, that's 1 order of magnitude, but if, it's a little more dramatic when you leave it in milliliters. So from 13 to 200,000 is a huge change. And so answer A doesn't make any sense. B still is only, I guess 2 orders of magnitude. We're looking for many orders of magnitude. So C doesn't make any sense. So if I'm taking the test, I'm like, okay, it might be D, or maybe this is another one where it's testing us on the none of the above. But if I, before you pick up your calculator, I would cross out A, B, and C, and it's either D or E. So on some of these, I mean, you took the test, and I didn't see too many people finish early. The time is sort of important, and the time needs to be important so that, people who, when you know how to do it, even if you save one for later, the last problems you're doing, that you actually know how to do it, and you're not searching through your notes to try and, find a similar problem to copy or etc. of the sort. Okay. Let me hit the. So, like I said, a shorter day, because I remember what it was like to be a student, and I'm sure you would like to enjoy a sort of a completely free week. I'm sure you have other exams and things to do. So we'll pick back up here Wednesday and start on new material, but I don't want to cover new material. So, if you did fabulous on the test, or you already saw the answer key up and went over your stuff, and you feel, where you goofed or whatever, and you feel comfortable about it, and, this kind of gives you a feeling for what the next test should be like. When you've gone through and done problems, note which ones take you longer, and try to, especially with the PDF, if you print it out, you can circle the easy ones and do those first, and leave the harder ones, or the ones that take you longer, for last. All right, I hit the unmute. So if you want to ask any general questions, if you want to talk about yours in general, I know some people probably don't want to talk about them or their score in front of the whole class, so we can, send me an email, and we can start a dialogue, or we can Zoom or something, or do that later.
I have a question.
Yeah.
The next chapter that we cover, is it going to be on gases?
That is a good question. I don't know, whatever it says on the syllabus, I think it is, but I haven't taught 161 in a while, and so I forget, but I could pull it up. I forget if it's heat or gases. I know it's out of order compared to
the textbook.
Yeah, the textbook. The material's all the same. Freshman.
It shows. Oh, sorry. Go ahead.
Freshman chemistry hasn't made leaps and bounds in the last 50 years.
Gotcha. Because I pulled up the next PowerPoint chapter. This is chapter 5, gases. So I started on it. I was just curious before I get too far ahead.
Okay, yeah, no, then we'll do gases. And even if it was heat or gases, one of those is the next. Yeah, mine just took a minute, but it opened up, and it's gases. So we'll do gases next, okay. Which I think in our book is like chapter
9, I think.
9 or 10, yeah, something like that. So.
Okay, thank you.
Yeah.
Is the next midterm solely focused on questions based off what we learned in that, like from here on to until the next test?
Yeah, so it's going to be on the chapters that we cover, but you got to keep in mind, chemistry is always, quite often going to be chemical reactions. So there won't be one on the test like you need to balance this, or the problems will be different, but you still need to know that things are balanced. We'll still use multiple ratios, and there'll be new, it's not like a history test where the Civil War has nothing to do with World War I. I mean, except that the North won, you know what I mean, though. So chemistry is cumulative. You can't forget the things from the past, because we keep building and using the molecules and etc. So, but there won't be these types of questions. They'll be focused on the material in those chapters, but you can't forget the stuff we've already done, if that makes sense.
Got it.
I think you'll see, especially like now you have a feeling for what, the next test is going to be, similar to this in format. And so you can take this exam and then go look at those worksheets and study guides we did. And that'll sort of give you a template to be like, this is sort of like a game of chess or poker, you against me. And you're like, what's he going to put on the next test? And you can go look back and be like, oh, there's, a similar problem from the worksheets, and there's a similar problem in the study guide. So, as we do these next worksheets and study guide, you'll get a feeling of like what to expect. Or predict. You can predict, closely what it should be.
Another question. This one screwed me up. Titration, that's pretty much the same as using dilution, correct?
So it is and it isn't. We have graduate
Like
students.
if you can walk me through like how this worked.
So the M1, V1, M2, V2 does work for a titration when it's a 1-to-1, when it's one acid that donates just one H plus and you have just one hydroxide. But if you have a base that had, two hydroxides, then it doesn't work. So we don't like to teach it that way, because if you'll come into situations where it will not work. So the way this works, since it's a 1-to-1, is that the moles of the acid have to equal the moles of the base. So you were given the volume and the molarity of the base. So that told you how many moles there were, right? That's what this is, right? Right? Moles, molarity is moles per liter. So when you multiply, the liters drop out. And this number of moles is the same for both the acid and the base. And so the definition of molarity is moles divided by liters. So you take that molarity that you found and you divide it by the volume of the acid that you used to get the precise value. So if this one was multiple choice, and depending on the answers that were there, but you can see that 8.4 is almost half of 17.1. So that means you needed half as much, so it must be nearly twice as strong.
Oh,
And right, 0.1, this is 0.203, but really close to just 0.2. This is one that's easier if you're taking lab and you had a titration. I mean, we covered it kind of just before the exam, but this is why they encourage and want people to take labs the same time as the lecture. And the lecture is supposed to cover material in class first, so that way when you're actually doing it with your hands, you're more confident in it. But for students that are taking lab and you already had a lab where you've done a titration and you've done the post lab, then a titration problem on the test is kind of easy. You've just had more direct exposure to it, so.
okay.
Anyway, the molarity one does work if it's a 1-to-1, but if it's if the stoichiometry between the acid and the base either way was not 1-to-1, so 2-to-3, 1-to-2, 1-to-3, whatever, then it doesn't work. So it's better to do it, this way and understand where it comes from and what's going on than trying to just plug in the dilution equation. And this one's almost identical to the one that's in the slides. I think all I did was change, the volumes or something. But the
Got it.
0.1 is a real common molarity for titration work. And the final is going to be cumulative, so we'll only cover like one chapter before we have the final after the last midterm. So basically, I'm going to take 5 problems off each midterm, change the numbers a little bit, or ask the question in reverse, that type of thing. So you'll probably see titration on the final. You'll see it once more.
Oh, I think I've got everything I need now. Thank you.
Okay, cool. I'll see you Wednesday then. And then there were two. Art, Ben, anything you want to talk
Yeah.
about?
The test question. Do you know any cool demos I can do with sodium metal? I bought some of that, besides just throwing it in water.
You kind of cut in and out. Say that again.
Are there any cool demos I could do with sodium metal? I bought some, and all I can really think of that's like safe enough to do is put it in like water with phenolphthalein. But
Yeah, you bought sodium metal?
yeah, just off you can buy it on Amazon, eBay, or Etsy.
Really?
It's expensive. It's $10 for 2 grams.
Did it come like covered in oil?
Yeah, a bunch of the oil leaked out, so I have to go buy more mineral oil. But
Yeah, so it'll be like you ever get sushi and like wasabi that's like exposed to the air. Like sometimes they put it in like a little, like the to-go ones in a little plastic tub or whatever. The stuff on the surface is kind of already reacted and is no good. It's the stuff in the middle. But
yes,
sodium's pretty reactive. Like when you throw it in water, it'll generate a lot of heat and hydrogen gas and it'll blow up. So it's pretty impressive in water on its own.
yeah, I know. I was just wondering if there's anything else. I know you can mix it with potassium metal and make like a knack, which is kind of cool too. But,
Yeah, I mean, but this is all like there's a fire danger here. I'm surprised you could buy it, or it must be low grade or something, I would think, because that's a strange thing for Amazon to be willing to ship. You know,
Yeah.
it's not as bad as the lithium in a lithium battery, but you can't ship that stuff to Hawaii, you know, or you're not supposed to. But I would just say
all right, well,
be careful with it and get that mineral oil, you know, before as soon as possible. Don't store it next to like, you know, a stack of newspapers, that kind of thing.
all right, yeah,
Yeah.
I won't.
Okay. Okay.
All right, thank you. Have a good one. See you on Wednesday.
All right. Sounds good. Bye.
Bye-bye.